Let's just get right into this explainer. Look, if you're a developer, a data scientist, or an AI engineer, you already know the golden rule, right? Data is absolutely everything. But actually getting that data out of the most common document format on the entire planet? Yeah, it's notoriously difficult. So today we're checking out a tool that's built to finally smash those data extraction bottlenecks we face literally every single day. We are looking at Marker, which is this incredibly powerful open source PDF converter created by Datalab.
I mean, it's a completely valid question. Why is extracting data from a simple PDF still a developer's worst nightmare? We have advanced AI, but we still struggle with this. And we've all been there. You get this beautiful, pristine document, but the second you try to parse it, the text is just absolute garbage. PDFs trap your tables, they shatter inline math equations into unreadable alien symbols, and they completely wreck that clean data ingestion you absolutely need for modern RAG pipelines. It's so frustrating to have the data right there on the screen, but it's functionally completely inaccessible to your code.
So here's the game plan for today. First up, conquering the PDF format. Then, what can Marker do? Third, supercharging with hybrid mode. Next, crushing the competition. And finally, we'll go inside the conversion pipeline. All right, part 1, conquering the PDF format. So, for a really long time, if you wanted highly accurate extraction, it meant shelling out for expensive proprietary cloud services. But Marker steps up as this open source hero, basically designed to tear down those paywalls. What I love, though, is that the developers are refreshingly honest about the challenge here. Right in their own docs, they literally say PDF is a tricky format. Very complex layouts with nested tables and forms may not work. And you know what? Acknowledging how inherently difficult and messy this visual-first format is, that actually builds a lot of trust. But as you're going to see, Marker is engineered to tackle these exact headaches head-on. Moving right along to part 2. What can Marker actually do? Let's do a quick, rapid-fire rundown of its superpowers. It doesn't just do PDFs, okay? It handles images, PowerPoint decks, Word docs, HTML, EPUB files, and it does it across all languages. It beautifully formats tables and inline math. It extracts and saves out your images while totally scrubbing away those annoying artifacts like headers and footers. And it spits out your clean data into Markdown, JSON, HTML, or this really cool format called chunks. Oh, and it also does structured extraction if you give it a JSON schema, and it runs on whatever you've got, GPU, CPU, or even Apple's MPS. It literally takes a visual disaster and hands you clean, usable data. Actually, let's pause on that chunks output for a second because it's a real game changer. So chunks is similar to JSON, right? But instead of a crazy, deeply nested tree structure, it just flattens everything out into a single list of top-level blocks from each page, and it keeps the full HTML of each block tucked right inside. Why does that matter for us? Well, because it's specifically engineered to be the absolute perfect injection method for RAG pipelines. You don't have to write some massive, fragile script to crawl a JSON tree just to rebuild the context. It's already perfectly packaged up for really flexible, easy chunking. All right, part 3, supercharging with hybrid mode. Now, this feature right here is what gives Marker a massive edge with those really tricky layouts. Take a look at the difference. On the left, you've got standard Marker. It relies on these fast, standalone deep learning models, and out of the box, it is super capable. But then, on the right, we have hybrid mode. By literally just passing a single flag, --use_LMR, you pair Marker's deep learning pipeline with an LLM. You can run local models with a llama or hook up an API model like Gemini 2.0 Flash. In this hybrid setup, it intelligently fixes the absolute worst formatting nightmares, like tables that break across 2 different pages, pulling values out of crazy forms, and just perfecting that inline math. And the data totally backs up how powerful this hybrid approach is. If we look at the FinTabNet table extraction scores, which basically grade both the structure and the content accuracy, standard Marker gets a really solid 0.816. If you just ask Gemini by itself to extract the table, it gets a 0.829. But when you smash together Marker's precise structural detection with the LLM's deep contextual understanding, that score shoots all the way up to 0.907. It's just clear-cut proof that combining these two distinct technologies gives you way higher accuracy than leaning on an LLM alone. Which brings us to part 4, crushing the competition. This is a total David versus Goliath moment for open source. When tested against a benchmark set of common crawl PDFs, Marker absolutely demolishes the expensive proprietary cloud services. Look at LlamaParse. It scores an 84.24 on the heuristic benchmark, and it takes a pretty sluggish 23.3 seconds per page on average. But Marker, it hits an unbelievable 95.67 and blasts through it in just 2.8 seconds on an each 100. It also easily beats MathPix and even Dockling, which is another really great open source tool in both accuracy and speed. So Marker isn't just some nice free alternative. According to the actual numbers, it's literally the superior tool. And hey, if you're sitting there wondering about scale, just look at this number, 122. That is the projected number of pages per second Marker can process when you run it in batch mode on a single H100 GPU. That's just wild. Because it's so memory efficient, using maybe 3 to 5 gigs of VRAM per worker, you can just spin up multiple parallel processes. It really highlights the massive scalability this thing offers for heavy enterprise-level workloads. All right, final section, part 5. Inside the conversion pipeline.
So, how is it actually pulling off these crazy speeds and high accuracy scores? Well, Marker takes this massive problem and chops it down into a really smart 5-step deep learning pipeline. Step 1, it extracts the text, and it only runs OCR via a model called Surya if it actually has to. Step 2, it detects the page layout and figures out the correct reading order, again, using Surya. Step 3, it takes those layout blocks and cleans them up, using fast heuristics and a model called Texify. Step 4, this is where it optionally calls in the LLM for that hybrid quality boost we talked about. And finally, step 5, it stitches all those blocks back together and post-processes the final text. But the real secret sauce behind its speed is this idea of precision processing. Marker is incredibly strict about only using heavy deep learning models when it absolutely has to. It just refuses to waste compute. It leans on blazing fast heuristics wherever it can, and it intelligently hoards your GPU power for the genuinely difficult parts of the document. That level of elegant engineering is exactly why it runs circles around those heavier cloud-based competitors.
Which really just leaves us with one final, kind of thrilling question. With the PDF bottleneck finally shattered by this incredibly fast, highly accurate open source tool, what are you going to build with all your newly unlocked data? I mean, Marker has practically handed developers the keys to tap into decades of trapped knowledge. Whether you're building the next big AI search engine, or a massive financial analysis pipeline, or frankly, if you just want to chat with a dense textbook, the barrier to entry is officially gone. Thank you so much for hanging out with me for this explainer. Seriously, get out there, pull down the Marker repo, and go build something awesome.